Good morning, everybody. Good morning, folks joining us virtually. We're going to go ahead and kick off this morning's sessions. It's on applications of artificial intelligence and robotics and recycling and material processing. Our moderator this morning is Sidney with Waste Solutions, and had the pleasure of knowing Sidney for a long time through the SERC network, and he has a lot of expertise on the equipment side. So that's why we'd like to have Sidney drive this train. So I'm going to turn it over to you, sir.
Okay. Thank you very much, and welcome to our session, 8:30 session. We've got 3 presenters. 2 of them will be virtual, and 1 is with me. So we'll have one from the Machinex group, David and Marcouiller, I think is how you pronounce his name. And so we'll start that now.
All right, so I'm the first one to go. I can't see you guys, so I don't know exactly how many there's in the room, but I want to apologize to everybody for not being there live. I've been attending the Southeast Recycling Conference for 13 years now or something like that. So it's sad that I missed this one, especially that I'm presenting, but I'll try to be as good and as quick as possible this morning on that matter. So there's questions, and Rusty is also in the room, so feel free to fire away. I don't know if there's probably a question session at the end or if it's right after I speak, but it can be a different format, and if it's easier, Rusty can answer some of them as well. We can go on as a team on that as needed. So without further ado, I'll get started on that. It's how AI and advanced sorting technology can help MRF operator with Manpower challenges. Obviously, we've done some of our research. This whole presentation is also asked, based on our perspectives and what we see as suppliers, as the demand and everything from the customers and the operators. I guess being here today, we all understand that technology, artificial intelligence, and advanced sorting is reshaping the face of the industry of the waste and the recycling. More and more, it's applied at different places in the system. It's applied for maintenance. It's applied on operational data. It started with SCADA system and all that, and now that we have that knowledge from the years past, altogether, we were able to apply that into newer sorting technology. The different subject that I'm gonna go over today is demystifying a little bit the AI concept, artificial intelligence concept, a vision system, robots, optical sorters, and other application. How AI reduces manpower issues, how AI reduces safety risks, how the AI improves the plant performances, plant operation, and a little bit of a look of what we see as the MRF of the future and all the technology application in it. So first, just to bring everybody kind of on the same page here, I'm sure a lot of you that are speaking with me this morning already know that. However, to bring everybody on the same page here, artificial intelligence, it identifies what it sees through a camera, which is the eye, pretty much the same way a human eye does. So it sees color, it sees shape, it sees characteristics, and it can learn from it. It can recognize the dirty material, commingled through forever changing situations, just like the sorter would do. It continually improves from operating experience to get a better, detection and identification of the products. It can, get the data all together and compare it to the other to generate the signals that it needs to generate. It can identify stream composition as well, based on the volumetric surface area. We pretty much, when we do AI, artificial intelligence in our robots, and in optics, it's the same way. We also always go by order of priority for task, and it's most likely always based on price. When we do sorting, when we do quality control, it's based on surface area to get what's heavy and large out of the stream when we want to QC a stream. But that predetermined order is something that we can play with based on the need. All of the data is also cloud-based. I think a lot of my colleagues here are the same way as well. So that way we can learn from one MRF experience to the next MRF. So in theory, it's pretty much like if you train a sorter in a dedicated MRF, you've retrained all of the sorters in all of the other MRFs if you want. So the vision system, the artificial intelligence can give you a dashboard, pretty much can get you a material characterization of what's going under the belt. It can tell you a runtime, can tell you a pick that it tried to do, combined with a vision system after, it can tell you how many picks it was successful at doing. There's a lot of that information that gets now available to the operator through the vision system. The robot, I had a few videos here. This is an example. It should be running. It's an example of a line where the robot is actually QCing an HCP line, picking the material that it can sort out of it. It's a short video. And I've got a second video where it QCs a Tetra Pak line. So same thing. You can see some of the products are also disappearing right when the robot tries to grab it. It's because of our the conduit that creates the suction on our robot is over 2-inch diameter, and some of the material can get sucked up straight to a cyclone, discharge cyclone on the side to prevent jamming in the nozzle. But that's a little bit what they do. You can see how fast they're moving and the kind of tasks they can achieve. So they're powered by AI. AI can also be utilized into optical scanners, combined with the hyperspectral. They can power the air jets, get the optics to do a better signal because they're combined with what even a human eye cannot see. So I'm getting to the Manpower part of my presentation now. It's just presenting all of that to show what it does and where it pretty much substitutes or help complement the manual sorting position into a so the AI combined with the hyperspectral in this case will get better signals and better decision-making process to the material and what it needs to do with it. That was an example where those signal combined are firing on brown material. So where we combine the vision system with the visible material with the hyperspectral in one optic. So we're ejecting down all of the plastics and up everything that's brown here. So how AI reduces manpower, that's the big point here. The vision system, so AI applied in vision system can reduce the required manual audits. So those vision systems are being installed into end product line or to the line that's usually going to the landfill, to the rejects. So we can see how the system is efficient. We can see if we're missing a lot of material. We can see if something's wrong with our optical system or other sorting equipment in the facility. So they basically reduce the need of manual audits because you can definitely see a trend. They can report a real-time tendency of the MRF. You can go with that. sorting robots, they're more like replacing humans. So they go on the line and they actually pick up material that you would instruct a sorter to pick up. They do it at a higher rate. We've all seen those super sorter that can sort 100 picks per minute. They just don't do it all day, and they're not necessarily constant. And when they don't show up the next day, that's affecting the MRF and the whole recovery system. The robot shows up every day. There's no break. It doesn't go on pause, and it doesn't shift his focus to something else, to somebody else talking to him, something like that. It just sorts all the time. So there's no retraining of the personnel. We all know on the HR side the challenges that are being handled about replacing sorters on a constant basis. So the AI and the robots are actually reducing a lot those issues and those costs. There's costs associated to retraining and hiring and all that. It says there are marginal wear costs. The wear items, those robots are made to do many cycles at a very fast pace. So there's suction cups. We've all heard about them. The hose system gets need to change at one point, but it's very minimal, the wear items. It's almost to the effect of giving gloves to soldiers and giving them PPE. Those costs would somewhat be in line on the long. And optical sorters, increase recognition of the optical sorter. I said that earlier. So they actually get the job done better now for the sorters that are down the line that can also be replaced by AI. The AI and robots are protecting workers from high-risk handling situation, needles, safety problems that can happen. We've all seen, plant either being shut down or something like that because of all of those needles coming in and being broke all over the place. This is something that's not too the robot don't suffer from, obviously. And with the AI and continuous learning, evolution, and optimization, the vision system, plant interconnectivity. Basically, this is giving you, the operator, a better vision of everything that's happening in the system, combined with SCADA system. The sorting robots, pick per minute versus the human, we just saw that better increased. And optical sorter, enhanced optical sorting recognition, trace versus PET, black plastic, white, gray, colored, and box board. So all of the better identification through this whole process. The challenge, the variation of the inbound material, the government regulation. We see a lot of EPR being installed in Canada here, bottle bill, all of that. The AI can adapt and you can improve your sortability around it. The artificial intelligence benefits, gets all of your equipment that are equipped with AI connected together in a MRF to give you real-time information as well, which sorters, wouldn't be able to do. They all do their job, but in the end, they don't report necessarily what's happening and how the material is changing and, should the system be adapted down or up because, materials not showing up on the belt or something like that. So all of those together are bringing you to pretty much a planet of the future where all of that interconnectivity of all of the AI technology gets combined together for a successful plant operation. Predictive maintenance, cleaning, failure, or something we didn't talk about necessarily yet. It's all of the information you can gather from the MRF. AI is not just necessarily a visible recognition. It can also learn from the breaks, learn from all the aspect of maintenance in the system. It can be integrated in failures and maintenance recommendation for the whole facility. And that completes it. I don't know if I took more time than I have or everything, but.
Hey, are there any questions for David? I wanted to point out a couple of things that I guess all the robotic companies and what you're looking for is the manpower that it replaces, which is extremely good, I think a good point, but also the safety that it you don't have manpower on these. The one I was looking at is the needles and that sort of thing. I think that's a big plus for these robots in general. One thing I want to ask you, David, I saw something about maintenance. Is that something that you guys do a preventative maintenance? Is it on a schedule? Or I noticed you said maintenance, but is it on a schedule or is it just as needed?
So the maintenance on the robot itself is on a schedule right now. The power of the AI is something that we have in our radar there, is to develop and combine that with the need of the equipment to learn from all the facilities together when the maintenance is due on not just necessarily the robots, but on the overall system. So again, this all goes very fast. I mean, 3-4 years ago, this was not necessarily even a topic in trade shows and conferences. Now it's in the middle of every new MRF that we build. So when I say that the need and what the customers or actually the operators are wanting is more and more oriented towards those maintenance and runtime and all of that, and that's right in the center of our efforts as well there to develop something that will help the operator better on that way.
Okay. Any other questions at all?
Hey, David, to follow up on the maintenance question, how are the training needs of the service techs evolving as robotics and AI becomes more integrated into MRFs?
Very good question. There's different level, and that would be very similar to the optics, I would say, is the training around the unit on a daily operation when it moves is not spectacular. It's just, cleaning up the robot when it clogs. There's self unclogging mechanism on the robots when it runs and all that. In our robots, we have a little canister on the side that needs to be emptied once in a while. And the rest of it is just, verifying the suction cup. Everything is clamped in. So the daily maintenance on a robot is fairly simple. Very similar to the daily cleanup on an optic. It's cleaning and inspecting, making sure everything's fine and changing those cups as we go. There's different level of training after that based on the customer and the operation staff that we have. Everything is connected to the office. And I've said it to many presentations before, 90% of the problems in a MRF are solved, that are related to controls and all of that, are solved over the phone. So everything is interconnected with our 24/7 online support service here. And basically, from a distance, we can usually see exactly what's on your screen and help debugging something if something happened. For the rest of it, there's different level of access that goes with different level of training that the customer wants. We usually give everybody the same level of training. And when it gets deeper, or when the customers are interested to know more about those little changes they can do themselves, we give them deeper access. Does that answer your question? Or
David, this is Rusty. I'm not, this is not a loaded question just because we work together. I'm a salesperson. I just kind of really need to know this answer. You mentioned black plastic, and we know that historically optical sorters have struggled with black plastic because it's the same color of the belt. Can you speak to how robots handle that?
So the robots are seeing better the differentiation on those black plastics items because they have labels, because they have different reflections. So basically the AI, which is more like a human eye. So if a human can identify a black object going on a black belt, so will the robot be able to do it. Our eye perspective will still have a hard time doing it, recognizing that material. And there's, in the past, we needed to use either a green belt to be able to see those black items and all that. Now the AI actually is being able to recognize and identifies those products by their family and category.
And
So as they move into the optics, like I said, when we combine the AI and in the upper spectral together, we're now able to get the best of both worlds. So we can differentiate the products from PP to HDPE to PET. Some items, some plastics items out there, they will look exactly the same. They'll be the same brand, but they'll be different positioned. Some will be number 2, some will be number 1. But so the AI itself wouldn't be able to do the difference, just like the sorters can. But eye perspective, it's always been able to. So by having those 2 signals combined, we can get that benefit. And on the other end, the eye perspective is not having the benefit of giving us the black, but the AI combined with it now gives us the benefit of being able to see those items that we weren't able.
Any other questions? No? David, thank you very much for that presentation. We appreciate it.
No problem. Thank you.
Our next presenter is Kevin Edward Walker. He's a product specialist for smart sensors and mechanical products with ABB. So, Mr. Kevin Walker, there you are.
Yes, thank you for the introduction. David, I really appreciate your presentation. It aligns a lot with some of the things we're going to get to talk about, and it was an excellent presentation. I learned a lot, so thank you. I'm going to share my screen, and we'll go directly into the PowerPoint, and then we'll take whatever questions come out of that. So let me know if you get some feedback, if you can see my screen. And we'll go to the PowerPoint. There, very good. You should be seeing a sort of a panoramic shot with a cell phone of a recycling facility. This is somewhere in eastern Pennsylvania. The customer here has actually given me permission to use these pictures and to use their name if I would, we can talk about that if we want to, but this is sort of a generic presentation. And what this is a case study. We're really just going to talk about one application we see here and what the ABB and Dodge business has done at this facility. So I appreciate your attention, and I hope that you'll find this helpful and interesting. We're going to focus on this machine you see in the center right of your picture, this DRS sorting machine. And you see these yellow stripes along the side. You're very familiar probably with this type of application. You've got a little SEW or Qantas style motorized gearbox here, and it's turning 15 shafts here and another 15 shafts here with another separate automation there. So this is this DRS sorter. Let's take a look at how that works. I kind of skipped the introduction, so let me talk a little bit about myself briefly. ABB is a huge company. We are making robots similar to the ones you just saw. I was very impressed with David's presentation. We make robots that probably do similar things. We have 4 separate divisions within ABB. One of those is called the motion division. That is motors and mechanical power transmission. That's the division in which I work. Within that division, the US-based mechanical power transmission brand is the Dodge, the old Dodge brand of power transmission equipment. So that's bearings, bushings, belts, connections, all that kind of thing. And if you're sitting in this presentation and thinking, I thought this was about robots, we're going to talk a little bit about artificial intelligence and a little bit about data-driven maintenance. And those were two of the questions that David really touched on, and I think you'll find that helpful. Anyway, I work in the Dodge brand of mechanical power transmission within ABB. So that photograph you just looked at, this is the plot or the schematic of what that actually is. And what you see is a MRF facility in Pennsylvania, 45 ton per hour single stream processing system. The DRS machine, this is kind of hard to read, so I just made it bigger here. You can see that it breaks glass and removes 2 inches in smaller pieces of glass, miscellaneous material, and paper from containers and paper. So that's what this DRS machine is designed to do, is breaking glass into small pieces and is removing those out of the application very early in the stream here. Just keep in the back of our mind what happens if this machine is down for any period of time, what that does for the rest of the production cycle. The inside of that machine, if you buy a brand new one, will look something like this. Now, they're not all exactly the same, but this particular model where our technology is being used, it has this bank of 15 shafts, and each shaft has a triangular shaped disc on it that is constantly turning against each other and designed to break that glass in that application. As time goes, that glass is very abrasive. It wears down those triangular discs that are on that shaft. It's a very aggressive, dirty application, and this is a wearable part within this machine. On the outside of the machine, again, you see these doors or these guards. These are safety guards, bright yellow. Behind that, you would see the bearings that are outside this machine on which these shafts turn. So what is going on at this process, and why are we talking about Dodge bearings in mechanical power transmission in a robotics presentation? So their current maintenance program in this facility is every 2 years, because these shafts have worn down so much, they have to buy and replace 30 shafts in that machine, 2 banks of 15. That's 60 bearings that they also replace at the same time. Not only does the shaft wear out, but the inner and outer ring, there's a looseness that's created over time because of the bearing being worn out. And their general maintenance practices every 2 years, we're going to take these shafts out and take the bearings out and replace everything and start basically with a new machine. That was done 2 replacement cycles ago in the summer of 2017. In January 2019, we launched a product called the Smart Sensor for mounted bearings. That's what you see on the right-hand side of your picture. And I've got a bearing I'd like to show you here in your camera. If you'll just hold on a second, I'll get that out. What we started doing in 2018 in preparation for this launch is we started machining our roller bearings to include, besides the grease fitting where you would re-grease the bearing, we started machining the product to include this smart sensor tag opposite the grease fitting, creating kind of an isosceles triangle there in the shape of that. That extra tag allows that sensor to be very easily inserted into the bearing. And the maintenance manager at this facility, when they got their replacement bearings in the summer of 2019, we launched in January this product line. In the summer of 2019, they got 60 replacement bearings. They all had this little tag on them. And that tag has a QR code that brings you back to our smart sensor landing page. The maintenance manager got in touch with us. We discussed with him the opportunity to put some sensors in his facility. And in the summer of 2019, they replaced all the bearings, but they also commissioned and installed 60 Dodge smart sensors on these replacement bearings. And that's sort of the case study we're talking about here today. Any questions about that or comments? I was at the customer site with the initial installation 2 summers ago, and this is what it looked like. These are the south A and B decks on the side. There's a catwalk, so it's very easy to access these bearings. Obviously, the guard has been removed here. You can see the bearings with the sensors installed. This is a motorized gearbox that is turning all of this business here. The same application here. You see our smart sensors installed on these 60 bearings. But that's basically the process. Commission the sensor, label it, get it attached within the ABB Ability Cloud. And ours, again, just like David mentioned for his process, ours is a cloud-based, data-driven system that allows the customer to know within an hour what his equipment is doing. So every hour, our sensor takes a reading, throws it up to the cloud, and he has all of his data available to him. We use a gateway to collect all of this data. This is a control box that is near these 2 banks of sensors. It's about 21 feet away. We've gotten data from over 600 feet in an outdoor application with this type of router. So we have very good connectivity here. We're constantly reading the data from these sensors. They operate with Bluetooth Low Energy, and they communicate back up to the cloud through this gateway that is hardwired into their local area network here. This is, of course, the south side again, where that catwalk is, and you see all of our sensors and bearings. We've got the guard put back on here and our gateway installed here. Another picture of that, we just wanted to show you how they look when they're all labeled. You see a little bit of a difference here in these two. When the customer bought the new bearings in 2019, they had some old stock shipped to them that did not yet have the drilled and tapped hole. Here you've got the sensor offset from the grease fitting here. In this case, there was no drilled and tapped hole. It's a brand new bearing they bought, but it was just old stock that was still washing through our distribution channel. So we sent them some of these adapters that we carry in stock that allow the customer to still re-grease the bearing and install and gain the benefit of the smart sensor. So that's a little adapter you see there on S12 as opposed to S15. This is the north side. You have to have a man lift to access it. That's what you see in the bottom half of this picture on the right, the top guard on that man lift. And then these yellow guards come off and you have access to the bearing behind a chain sprocket. It's very challenging to clean in that area. It's challenging to replace that bearing. It's a lot of downtime if a bearing goes out during the middle of a production cycle. So again, you see the support sensor here, and in this particular side, because it is accessed by a man lift, they have an automatic greasing apparatus here and lube lines running to the different sets of bearings. Another picture of that same application, you see the automatic lubrication system here, and then you've got lube lines running to the bearings here with sprockets. That's what you see on the right, the north A and north B decks of bearings. So that's basically the installation. So we've talked a little bit about their maintenance process. We've talked about the installation of smart sensors in this facility. What does it all mean? What does that actually mean for the customer? And what has that meant for our business as well in helping them understand what's going on with their equipment? Here's the final picture of this installation. You see we put another gateway. That is a temporary location. It's actually mounted on, I think, this bracket here in a more permanent mounting, but we're using this conduit to run our wire. And that again is through their local area network, a second gateway. It's a redundant system. You only need one gateway in this particular application because of the closeness of the sensors to where the gateways are located. But we have 2 of them in case they have a power failure. One of them might still keep, if it has on a different power line, might still be collecting data. So what is the problem in this application? And, you know, I'm of a certain age where my kids are nearly grown. I've got 2 still in college, but they're out of the house. But my first child was born in 1996. And in 2001, if you wanted to watch Bolt or The Incredibles or Over the Hedge or, you know, for my daughter, any of the princess movies, Cinderella from Disney, you had to go to this little store called Blockbuster and rent a plastic video cassette. Now, for those of you under the age of 40, you don't know what that is. So that is a plastic box about this big, and it has two plastic wheels that turn in it. Wrapped around those wheels is magnetic tape. That tape is designed with a very high tensile strength. You can cut it, you can tear it sideways a little bit this way, but it's very hard to break just pulling on it. And what happens is these plastic cases come apart and similar devices like this, and that tape comes out of those spools. And if they make it this far into the application, they start to wrap around those triangular disc shafts on the inside of the machine. When they wrap around that shaft, they create a binding in the bearing. And what they will do is they will actually crawl down the shaft until they're cutting into the backside seal of the bearing. Once that's happened, that shaft may turn a few more cycles, but that bearing is gone. Once that seal is destroyed, the bearing is shot, it's destroyed. You're going to destroy the cage, the rolling element. Within a day, the bearing has to come out. And here you see a really good close-up picture of some, it looks like paracord or maybe a string from an onion bag wrapped around that shaft. What that binding on the shaft does, though, is it creates radial load inside the bearing. And for those bearing engineers out there, what that means is that's going to cause a change in temperature rapidly. And what we found is what we're going to look at next in the next few slides. So I personally blame Walt Disney for all the problems we can have with these bearings. He's the reason why we had all these black plastic cassettes so many years ago. There's a box of those in your attic, probably. You need to throw them out and make them into digital, but that's a significant problem and things like that. Here you see a bunch of material on the backside of this bearing. In 2021, actually about a week and a half ago, our sales guy was on site with some of our technicians here, and we replaced all of the bearings with new bearings, their regular replacement method. So every 2 years, they replace all the bearings and they replace all the shafts. And this is sort of before and after picture. Since they were approaching replacement time, they relaxed a little bit some of their cleaning standards. So this is probably worst case scenario for the dirt on these bearings. But again, this is before and after, and now you've got brand new bearings. The smart sensors have been replaced. All the data, historical data is maintained. And you've got basically a brand new sorting machine, DRS, debris roll screen to start with the next day. Again, look at that picture of that contamination in that center bearing on the left there of wrapping around that shaft. This is a short video we're going to play. I hope you can see this. I don't know if you'll be able to hear the sound on this, but I think this is interesting. You can actually see something turning with the shaft on that one. So there you can see, just in sort of a real world application, what that actually means for these bearings. When we're looking at those shafts on the inside of the machine, the customer pointed out to me that this is a really good example of how these shafts wear down over time. You see the edge, sort of the rectangular edge on this glass breaker, how sharp the corners are, how sharp the little flanges here, the squareness of it. And then look at how rounded off these have become over time. Look at the gap that you see here. This is not supposed to be here. So this creates inefficiency in this machine as these parts wear out over time. So this is right before replacement. He actually was able to stick his hand down into that hole and show me. Of course, we were locked out and tagged out to do this in a safe manner. But he was the maintenance manager was actually able to show me how far apart these have become over time because that abrasive glass is wearing that metal down. Again, this looks dirty here, but it's actually a very clean setup. They've gone in, they've replaced the shafts. You see how tight they are. That gap is not showing there. These teeth are interlocking. It's ready to go to start breaking glass again and moving equipment through their MRF stream. So this is the dashboard, and this is what the customer pointed out to us. So when that paracord starts to wrap around that bearing, or onion bag strings, or magnetic tape out of a cassette, what happens is you have a binding on the shaft that creates radial load in the bearing, and that causes our temperature in our smart sensor to go within a couple of hours. So each data point is an hour. So in the first hour after startup, we went from 74 degrees to about 126. So you have about a 50-degree temperature swing. Of course, the binding is still there. The next hour, the data point is up to 190 degrees. We've tripped an alert level, so the customer gets a notification on their phone. You've got a temperature issue on this particular asset. And then it trips an alarm level. He gets a second notification that you've now reached alarm status on this particular bearing. It comes down at night when they're not operating, or at lunchtime they're not operating, and then they go back in for the afternoon shift and they still have some temperature issues. At night, they go in, they do some maintenance, and they remove the tape, and then you see the next several days, they have pretty much normal operating condition, normal temperature after cleaning that. So it's a very black and white, very easy to understand. There are vibration levels we take, and we can use that. We're using that information in artificial intelligence. We've got 60 bearings here, and that gives us some predictive capability with artificial intelligence. But the Dodge business probably ships, I'm just going to try to remember from my time in that business unit, we probably ship 20,000 of these individual 1 and 15/16 shaft bearings every year. We start to get smart sensors on any kind of percentage of those, then we will know everything at that point. We give 10,000 bearings of the same shaft size, turning the same speed, and we're collecting data from them. We'll know everything. We'll know your bearing's got 3 months of life left. You need to be greasing it this many times per week. Exactly. It will be true predictive rather than preventive maintenance. But for us in this application, we have 60 bearings doing exactly the same job, and we're using vibration analytically, but we've really found that temperature is the key for us to help this particular customer. This is an email from August 8th, 2019. So this is a month after we did the installation. Excuse me, this is about 2 weeks after we did the installation. Kevin, I hope all is well. We had one save from the data. Those number 15 shafts had wrapping on both the north and the south sides. We were able to drop the bearing temperature by 80 to 90 degrees. And then we had a conversation about coffee, and so we had an extra comment there. But this is from the maintenance manager at this particular facility in York, Pennsylvania. So I've talked a lot, and we're going to get some questions here if you have some questions, but I wanted to give you what the actual results, what are the real world results after this 2-year test case of smart sensors in this one application in the MRF stream. So our planned replacement process is every 2 years, we replace 30 shafts and 60 bearings. We did that in 2017, but we didn't have smart sensors. We did that in 2019, and we included smart sensors. And we've now done that again, including smart sensors in 2021. When we talk about bearing saves, in the 2017 cycle, they had 10 bearing failures outside of their regular 2-year replacement. In other words, between 2017 and 2019, they had to replace 10 bearings because that wrapping got so far into the seal area of the bearing, it destroyed the bearing and the bearing has to go. That means if they can't get the bearing off the shaft very easily, they take a grinding wheel and they attack that bearing from the front and side at an angle, and they grind off the cast iron and the steel down to the shaft level here and here. Now the bearing is in 2 pieces and they're able to get it off the shaft. They've damaged the shaft. They've got to go in with machining and polish that shaft. Now they have an undersized shaft they're working with, slightly undersized shaft. They've cleaned up the shaft and they've installed a new bearing, but they had to do that 10 times outside of their normal replacement cycle. Now, if they have a contract through a distributor with Dodge, they're paying $300 and something per bearing. So that's $3,500 in cost that they encountered because they had to replace 10 of those bearings. In the 2019 build, we've replaced 2 between December 2020 and when we did our full 20 bearing replacement here a week and a half ago. So we replaced 4, but they were sort of towards the end, okay? And they were more as a result of looseness than having the seal to be destroyed. Basically, the shafts have become so warped, they have wallowed out the inside of the bearing. So that's a 6 bearing swing alone there that is going to be a cost of, close to $1,800, $2,000. Not a lot of money, but it is something for them to consider. That's on the bearing side. Now let's talk about unplanned downtime. This is a 45 ton per hour single stream MRF facility. In 2017, due to these 10 bearing failures, they had 16 hours of unplanned, unscheduled downtime. With the smart sensors, we were able to warn them ahead of time about these 4, and then the other bearings where they had wrapping and they were able to clean the bearing and save the bearing, we were able to warn them as well, especially using that temperature guide. In the 2019 build, on this particular machine, they had 0 hours of unplanned downtime. Frankly, that's almost too good to be true when I look at those numbers. But in talking with the maintenance manager, he explains all of it. The data is giving us an early enough warning. We know the bearing will last a couple more weeks, and we can replace it when it's convenient for us. So from 16 hours to 0 of unplanned downtime, you guys know probably what your numbers are, your cost for the machine to not be running, the cost of not operating. You know what those values are. You can interpret that based on your facility. And then finally, when it comes to plant efficiency, and this is the big one in my book, the numbers don't sound that impressive, but if you've dealt with plant efficiency numbers, I think it will make sense to you. The 2017 build went from 95% plant efficiency. And then based on the change of not having these 16 hours of unplanned downtime on this machine that's at the very front of their stream, they went in 2019, they had 97% plant efficiency. 2020, they had 98% plant efficiency. We gave them a score in that 2019-20 build years, those 2-year average of 97.5% plant efficiency. So they gained 2.5 percentage points on their plant efficiency through use of the Dodge smart sensors in their application. Again, those are, in my mind, almost numbers that are too unbelievable to be true, but we have the data that backs it up. We have all of the reports. We give this customer a weekly report showing him what his sensors are recording, sort of a snapshot report of the overall plant efficiency, how the bearings are doing, and then an individual report, if he would like to reference that, with what data each sensor recorded over the previous week. That is the particular program. Those are the results, and I really appreciate the attention you guys have given to this. If you have any questions or comments, or feedback, I'd appreciate whatever you guys have for us there.
I do actually have a question from here. I don't know if you guys can hear me.
I can hear you.
Cool. Quick question. So we see it applied to existing bearings or bearings that you can take from the shelf with your adapter. We have some machines that we design that are also this screen where we actually custom build a kind of bearing to switch those shafts that are true shafts to so the shaft can now be quick coupling. So those quick couple, housing and bearing housing, we custom built ourselves. Can we, is that something that we can just drill an extra hole and apply your kind of detection process onto kind of any type of bearings that we manufacture?
Right. You have to create a 1/827 national pipe thread hole. You create that hole, you can put it on the engine block on your car.
Okay.
You can put it on your pool pump. I assume you have the big in-ground pool since you're the executive president of sales, right? So you can put this anywhere. I actually put this on a magnet. We don't sell a magnet because this requires an adhesive, which means it can come apart. And in the applications, we work a lot in the aggregate sand and gravel applications.
Okay.
And we don't want pieces coming apart in those, in any application. But again, you create that hole, you can put our sensor on. We have lots of customers in paper mills that have enclosed bearings behind a bulkhead. They're drilling a hole in the bulkhead and they're screwing the sensor into the bulkhead.
Yeah. And I don't know if I missed it or if you already said it, but do you have just a rough budgetary idea of like the screen that you showed, that screen there, that glass breaker screen, to convert that screen from just dumb bearings, right, to a full unit that's kind of integrated with the little dashboard that you've got
right
there?
Right. Our current approach to the market is you bought the sensor, therefore you own the data.
Okay.
So we don't charge a customer to look at their data. Now, if we're working through an OEM, that would be our deal with the OEM, and whatever they have with their customer, that's not really our business, right? But we don't charge to look at the dashboard, and you can, once you have the sensor, you can look at it on a phone or a gateway. And sensor, we go through distribution, so I can't give you the exact number, but between 220 to 240, 250 probably the highlight per sensor. You could outfit that entire DRS machine with 2 gateways for between $12,000 and $15,000.
Cool. Thank you for the answer.
Yeah.
Any other questions?
Kevin. Kevin,
I heard yeah, go ahead.
yeah, Kevin, the sensor that you had there, is that just temperature sensor? You mentioned vibration. I didn't know if it did more than one thing.
Yes. Right, so this particular sensor measures temperature and vibration, and in the sensor itself, it computes a root mean square average of temperature as acceleration and temperature as velocity, vibration as acceleration and vibration as velocity. And it communicates that data up to the cloud. However, you do have the ability to, on demand, tell the sensor to download raw data, and then ABB Ability will convert that into a fast Fourier transform, and then you can look at, a time wave spectrum. If you have an analytical guy that, I want to know where at what frequency and how high my amplitude is getting. You can use that. We are launching fault frequencies for Dodge bearings in particular in the upcoming months that will go along with this particular data collection device, but temperature and vibration. We have lots of algorithms. We calculate runtime, we calculate plant efficiency through algorithms, but temperature and vibration. Good question, thank you.
Any other questions? Hey, Kevin, I just had one observation. You mentioned, if I'm right, a gateway. Is that what
Yes.
you put up, a gateway, and I guess it communicates with this sensor?
Yes.
A lot of MRFs that I see have a lot of frequencies bouncing all over the place. Do you have the ability, I guess you have the ability to relocate or flexible where you put that so you can minimize or maximize connectivity and minimize
Yes.
interference?
Yes.
Is that wireless or wired? I know it's probably wireless to the sensor, but the gateway itself is wired?
Yes, so I'll just give a very quick explanation of that. And this is Sidney, correct?
Yeah, it is.
Yeah, thank you for the question. I didn't go into a lot of introductory material for the sake of time. But the gateway itself is powered by a local area network or a PoE injector, which creates 57 volts DC, which is typical laptop voltage. And so here's where your power supply would connect with this gateway. It's an Ethernet port, but you don't have to use that for the data. So you're exactly right. The sensor is scanning its environment, the gateway scans its environment, and it's reading the Bluetooth low energy signal out of any Dodge sensor. When it reads that signal, it's actually reading an advertising packet out of the sensor. So you're at a trade show, right? And you've got 2 cell phones, an iPad, and a laptop with you. So you are, in an Apple Watch, you are exporting 5 advertising packets, Bluetooth, probably in your seat, right? So the gateway reads the advertising packet from the sensor, and what our engineering team has done is they have put all of the data into that advertising packet. So every second and a half, the sensor says, "Hi, I'm a Dodge sensor, look at me. Hi, I'm a Dodge sensor, look at me." So that's being exported, Bluetooth low energy, by each sensor in range of the gateway. The gateway scans its environment and throws that data up to the ABB Ability Cloud. How does it do that? First, with a local area network. In this particular example we looked at, the customer brought their IT department in. We had some discussions about cybersecurity with their vice president of IT, and then they agreed to hardwire this device into their local area network. You can also attach it to a Wi-Fi network in your area. So this will export data via a Wi-Fi, just like if you have Wi-Fi router at the airport or in your home. The third way this gets data out, and I'm going to step away from my camera for a second here. This is a cellular modem that is packaged with a cellular connected model that we sell. It's obviously a lot more money. It includes, with prepaid, 3 years of data with either Verizon or AT&T. So you have this modem, you have 2 cellular antennas that are already attached. It's pre-configured, it's pre-set up. You take it out of the box, you plug it in, and it's exporting data. There's a little slot for the SIM card right down in here. I don't know if you can see that, but this is the plug and play model, and it uses cellular connectivity. It avoids the customer's network entirely. It scans Bluetooth, reads the sensor data, and then throws it up to the cloud through the AT&T tower or the Verizon tower. That was a really long answer. I hope that answered your question.
Thank you, Kevin. I appreciate that. Any other questions?
Thank you, Sidney.
Thank you very much, Kevin. Our last presenter is Richmond McGee, Director of Enterprise Sales with AMP Robotics. I'm sure everybody's heard of AMP, as well as all of them.
Thank you, Sidney. I'm Richmond McGee. I'm with AMP Robotics. I'm glad to be here today and grateful for the opportunity to speak. Thank you, Gene, for inviting us. And I thought David did a really good job of kind of sharing an overview of the robotic systems and some of the benefits of bringing in some automation through AI and robotics into the recycling industry. So I'll try not to repeat too much of that in my presentation. Excuse me. Really appreciated Kevin's kind of automating some of the MRF operations, limiting downtime, and kind of what I want to talk about today is using the AI really to get some of that data to really help make better informed decisions. And really what we do is around the material characterization and what's coming into the MRF and how we want to sort things. So let's get into it. Let's see here. Figure out how to use this. All right. So our mission at AMP is really to fundamentally change the economics of recycling. We want to reduce the cost of the sortation by using automation. And so We do this by trying to create a repeatable process. Now that's hard, right, with our material streams, because where some robots in the industry, and they've been around for a long time, just do the exact same thing, let's say putting a weld together or fabricating a car, they do the exact same thing every time, so that's their repeatable process. But for us, we're looking at a material stream that has a lot of different things on it. So you can see in this image, this is one of our vision systems looking down at the line, and the same piece of PET or the same shape of PET bottle coming down in the exact same spot, that's just not going to happen, right? So we've got to be able to design this system to where it creates a repeatable process, but it's going to be grabbing different types of material that are in different places, and this material is different shape. And so how do we do that? This problem for MRFs is really it creates a high cost, right? Because really until about now, we've had to use very mechanical devices to try to sort, separate, and then also use a lot of human labor. And so there's a high cost to get these commodities out. And so, we are trying to use our technology to really drive down the cost of this, and it's all made possible by using this data-driven approach and really using it strategically within these facilities. A little bit about us and kind of where we're coming from. We were founded about 7 years ago. Our founder is a guy named Matanya Horowitz. If you guys ever have the pleasure of meeting him, he's a very humble guy. You never know by meeting him that he is a genius. He got 5 degrees in 4 years, and he was a PhD by the time he was 30, and just an incredible guy that has really embraced this mission to drive down the cost of recycling. He's very passionate about it, and our whole company is geared towards it. We don't do anything else other than the robots and the AI associated with the robots. And so we're not a system integrator building conveyors and other pieces of equipment. So this is our sole mission, is to use our technology to help the recycling industry. We have brought on a great group of investors in our company so that we can scale and so that we can continue to grow. Some of the smartest, technologically astute venture firms out there have invested in us, which speaks to kind of our intellectual property in our technology of how we build the artificial intelligence and our neural network. We've received over $70 million in investments from companies like Google and Facebook and I'm sorry, some of the same investors in Google and Facebook and Tesla and SpaceX. Those same investors have invested in us, along with Google Ventures is one of the companies that has invested in us, and XN and Valor, closed loop partners. Also, we've secured capital from organizations like the Department of Energy, and which has really enabled us to push advanced technology and also partners such as Idaho National Labs. So along with the investors, we've got some great industry partners. We partnered with Waste Connections, GFL, companies like Keurig, Dr. Pepper to help really categorize the material streams. We are based in Denver, Colorado. All of our robots and our vision systems are made here in the U.S. And we are scaling. We've got 3 facilities now in the Denver area. We've got over 150 employees, and we are expanding internationally. And we are on 2 different continents now, and have big plans to keep on growing. So some of the challenges of the industry, the biggest challenge that my customers face right now is labor. I'd say, 2 years ago, we were talking a lot about the ROI and, how much does labor cost versus how much does a robotic system cost and automating. Now the conversation, has really shifted towards how can we make this affordable? How can we make this work? Because we can't find labor anymore. And, big part of that's due to COVID. Also even before COVID, there was just a lot of churn for these types of positions. And we see that the labor shortage just getting tougher and tougher. And so more and more folks are wanting to move towards automation. So, the challenge of replacing a human sorter with robotic system is a really complex thing. We've built a system that works a lot like a human. So if you imagine, the eyes of a person looking at the line, their brain telling them what that thing is, and then their arms going to pick it up, you can envision the same, type of system. And so 3 parts, it's literally a camera that looks down at the line, and it's seeing all of the material that passes by. So one of the things that David mentioned was, needing to be able to see all of that material. It sees in 2D, so it's not going to be able to see under something like perhaps an optical sorter could. So we want a really well spread out stream to make the vision system be able to see everything and recognize everything. That image is going to go to our brain, our computer system that sits there, and it's got our proprietary neural network on it. So that's what's going to actually detect what the material is. From there, the brain will tell the robot, we want you to pick out the PET, we want you to pick out the HDPE, whatever our customers have these robots programmed to do. Here's just a look at another line. This is, a snapshot into what a lot of our lines look like. Now, this one is not as singulated as we would like it to be, but you can still get a really good idea of how the artificial intelligence is seeing these things. So again, the eyes of the operation are sending this image to the brain, and the brain categorizes. But this is, like I mentioned, a complex task because the images on the computer are just simply a bunch of individual pixels. I'm sure you guys have all zoomed in really close on a picture, and ultimately it's just a bunch of dots. So given a sample image with many different objects, how can the computer recognize which objects are actually present? The computers think in bytes, so we must first represent this image in a way that the computer can think and then begin to construct a data model on top of it. And so at AMP, we use leading edge algorithms to accurately identify and locate objects of an image on a conveyor belt packed with recyclables and contaminants. The basis of this all is the machine learning. I'm sure you guys have heard that. So for the machine learning, what we have to do is we have to first categorize different things, and we've got a team of data analysts that do that. So we've got to build these categories out, and then the machine learning can begin to take place. So these are some of the categories. We've got over 100 categories. We've got about 19 major ones. You're going to have your your plastics, number 1 through 7s, paper, different grades of that, obviously metal. And so, we have hundreds of robots out there now working in the field. And so what happens in practice is, the computers are seeing these images. They have categories built out that they're assigning different material types to. Our team of data analysts is in charge of making sure that those categories stay correct. Material can look very similar to one another, and so to not get those categories crossed and mixed and confusing the artificial intelligence is a big part of what our team continues to do. Also, as the material stream changes and new products come out, we're also making sure that those are assigned to the correct categories. You know, products can have, we use, the AI is built on features or cues, and so branding is a big feature, you know, so, but a same brand, like an Ensure bottle, can be PET or HDPE or polypropylene with the same wrapper on it. So how do we teach the system that the same looking brand is actually can be 2 or 3 different commodity types? So we have to use other features like how big the lid is, or what the bottom of the bottle looks like, or the shape of the bottle. All of these things go into our AI and our network, and we literally use millions of different features to correctly identify all of the different commodities. This is a video, I might have to click it again, but this is just showing you, so we've got the vision system obviously looking at the line, and then we've got the brain telling it what it is, and then you pair that with a robot behind it. And each one of our customers, you know, is telling these robots what they actually want their job to be. These robots work anywhere from say 60 to 100 picks per minute, depending on the application, depends on the cycle time. The cycle time is how long does it take the robot to pick up an object, place it in the chute or the bunker, and then return back to work. Kind of a standard for us is about 0.75 second cycle time, which equivalates to about 80 picks per minute. Comparatively to a human sorter, that is you know, about twice as fast. You know, we've done some studies and research and watched human sorters over an 8-hour shift, and a human can do 80 picks per minute, but the likelihood of a sorter doing that over their whole shift and you know, not slowing down is unlikely. Seems like every MRF has about, you know, one sorter that's their star sorter that they love, and they said, man, if I could just have 5 more like him or 5 more like her, we'd be in good shape, but it's just really hard to find those people. So this is, you know, the power of the network and the machine learning is such that, you know, if you studied all of these materials and you never forgot what anything ever was, and then you had the benefit to know everything that everybody in this room ever learned as well. That's the power of our network. And so as we get more and more robots deployed and vision systems out there, the data is getting exponentially bigger and stronger and more accurate. Oops. Let's see if I can go back. This is a facility in not too far from here. It's in Sarasota. They've got 14 robots deployed in that facility. 8 of those are on the fiber lines, so doing QC on a negative sort on the fiber lines, and then also a lot of quality control on the containers as well. Again, the robots can have, you know, a number of different types of programming, but negative sorting, removing the contaminants, positive sorting, picking for value. So depending on the application, we will have the robot do different things. I get asked a lot too, like how much can the robot do? Well, you know, that's really limited by how many chutes that we could have on each side of the line. So if you just want to put, you know, for a less sophisticated facility, let's say you just have a container line after a screen, you could have that robot picking, you know, all of your plastics out. We just have to have places for those to go, and so we've just got to design it such that the reach of the robot is able to do that job. But as far as the programming of the robot, you could pick every single category we have if you wanted to, or just one category. So kind of bringing it back to, you know, the real message of this presentation, and how do we use some of this data to get better at what we do. So a conventional sort process, you know, as you guys know, with some screens and different types like that, like it's going to get some of that material over using shape and weight and different things like that. With the AI-enabled sortation, we're really using vision and knowing what that material is, and then using the robots to actually sort that material out. We can put these systems, you know, really anywhere in the MRF that we can see the material stream. As we get better and as the MRFs change, you know, the further upstream and downstream we can go. I would say right now the ideal locations for a lot of these systems is, you know, kind of after some sortation has already been done. Some locations we can put the systems up on the in-feed conveyor. We want to be able to see all of the material coming in and know what zones brought different materials to the MRF that day. Maybe there's a large contamination in one zone and that you need to go educate the community. Well, you can know that by putting the vision systems up ahead of your sort stations, knowing exactly what's coming in. On the other side of the MRF, you might want to know exactly what's going in your baler. And so, you know, if you've got a good spread of the material and you can see that, then you might be able to dictate a higher price for your material because you know you don't have as much contaminants as maybe some other guys. And so you can use that data to drive a higher value for your material. Then throughout the MRF, you know, knowing the data at your different lines could clue you in on maybe your optical sorter is not working, or you know, maybe you need another sorter because you've got so much contaminants coming down, or you know, I've got one slide in here that on the residue stream that, you know, you can know how much value you're actually losing because of a lack of sorters, and so then that might clue you in on, all right, we need some equipment upgrades. This is our standalone vision system. So, you know, this is the same, this is the eyes and the brain, just not the arms, the robot behind it. And so, you know, along with the robot systems, we can also just put these systems in as well, like I was speaking of on the, you know, the in-feed or throughout the MRF or right before the baler. Just depends on, you know, really the spread of the material. Sometimes we can help that by speeding up the belts or doing something ahead of the stream to really get the material on a good spread. But this is just a standalone vision system that will let you have the data that you want to make the educated decisions. So some of our customers, you know, use these things to really have that operational transparency, audit lines, QC lines, residue lines. This is one example of one of our customers who put a vision system on the residue line, and we saw that they were losing about $150,000 of UBC a year. And so, you know, putting a robot sortation in, you know, not only helps them generate that revenue, but also reduce their cost of going to the landfill. So what does the road ahead look like? And, you know, as we build new MRFs and as we discuss, you know, kind of how to use this data within the MRFs on, you know, for customers that are building new MRFs, you know, really having these sensors throughout a MRF and building it in a way to where we can see the material becomes kind of the, you know, the data-driven way to sort material in a way that you can see what's coming in, you can see what's happening throughout, you can use the robots to divide up the material. You know, the robots will work 24/7, and so, you know, whereas some facilities are built to run hard for 8 hours and try to get all the material through, Some of our customers are now talking about, how can we, if we can fully automate a facility, we don't need to build it as big, but we can keep running the material through and have kind of that skeleton crew that just makes sure that the system keeps running. On that, you can rerun that material because you know exactly how much material is left for the robots to grab. So if you see that you still have a lot of value going in the stream because you can see all of the data of what's going through, then you can keep running that. The robots have a finite number of picks that they can do. They can do about 80 picks per minute because it's grabbing each object. So a magnet is going to get every piece of metal it sees. An eddy is going to fire on all the aluminum. But a robot, works a little differently. It's having to take that time to go grab it. So it's slower than some of the other pieces of equipment. We don't discourage all those other pieces of equipment, but we just know the places the robots work and we know its abilities, and so we just want to set those expectations as such. But kind of like David said in his presentation, these robots show up every day, they work hard, and then the data that we can get from this can really help us make educated decisions on how we operate our MRF, and then also, really just in forecasting your business, using this data to know how much material you have and where it's coming from. And so with that, I'll wrap it up and open it up to any questions.
Anybody have a question? Yeah. There's one in the back, too.
So one thing that, you mentioned is that the robots see it two-dimensionally. In terms of what's coming, do you see three-dimensional or density scanning as a innovation down the road?
I think there's a lot of cool stuff that you could do like that with these systems, and we've looked into some of that stuff, and some of the work we're doing with the Department of Energy is kind of along those lines. We've got a huge team that is full of really smart people that are constantly pushing the limits on what we can do and how we do it. So I couldn't say for sure that we're going to be doing 3D, but getting one thing that we can't do right now that we'd really like to do and that we're working on is know the weight of things. So we can see the size in the 2D, and we'll put a size dimension on it. But if it's a piece of cardboard or if it's a really thick book, our system right now is going to kind of see that and weigh that the same. So how do we get to that level? Is it through 3D or some other way of sensing it? I do think that's coming, but nothing to speak about yet.
How does the training and maintenance of these systems work? And then also, what if the robot gets confused and starts sorting something else?
Okay, great. So how does the training work? And then what if the robot gets confused? And then maybe a little bit about maintenance? Okay. The training, when we go into new streams like C&D and organics and e-waste, which we're in those, the training is really up to our data analytics team to be able to categorize correctly and to make sure that the brain is growing correctly so it's got a good neural network. When we put these systems into a MRF now with the common commodity types, there's not a whole lot of training that goes on. Our systems are already, that brain is already built. So if you put a robot in your stream, at least in North America here, that training has already taken place. We've already done that work. The robots, even though it's artificial intelligence and they have the ability to learn, they don't really get confused like that. We've never had a robot that we've programmed to pick PET and it says, oh, I'm going to start picking HDPE instead. Maybe someday that'd be kind of scary. So, the robots haven't gotten confused in that sense. As far as the maintenance goes on these things, there is daily maintenance, checking the suction cups. we call the suction cups, the grippers, it's like the gloves that the humans wear. Those are going to wear out. We know that's a consumable part. So those can break, and if you keep those fresh, and if you clean out the shaft, which is the main source of the suction power, that can get clogged. So we've got a bottle brush. You clean that out, and the system stays up and running pretty well. A couple other little parts that you've got to replace every now and then that we know are going to wear out. But overall, the uptime is fantastic on these machines because it's pretty simple. I mean, it's a robot. It's got 4 servo motors that control the arms. That's connected to a pneumatic panel with a couple of different valves. But the hard part of this thing is the software that's running it. 2 bits of software run it. It's the AI, it's the recognition of all of this stuff, and then it's the actual robot controller software, which tells the robot that it's pick path planning. So which object am I going to go after, and what pattern and am I going to take it to get there? And so we've got 2 teams that run both of those kind of divisions of software internally. And the robot engineers are really trying to push the robot as fast as it can possibly go without breaking itself.
So is there a weight limit on that suction? I'm envisioning like a container that still has product in it.
Yeah, there is a weight limit, but for the single stream MRFs, that's not usually a factor. It's 10 pounds of payload that we can get. So if let's say an optical tries to fire on a full water bottle or something like that, and it misses it, and then it comes through the robot system, our robot's going to be able to grab that.
I have a customer in Denver, and they were telling me that you guys built your own facility in Denver with no robots. I'm kind of curious. You're running your own facility now, and what are you doing in that facility?
Yeah, that's a good question. We had a press release about that about 2 months ago, and so he probably hadn't been in that facility because it's full of robots. So we're using our technology as a secondary sort processor. So we're taking residual from MRFs in the area and running it through our technology. So it's our AI, it's our robots that are sorting. And yeah, it's using all of our technology. What we found was MRFs have an ability to clean up a certain percentage of the stream. They're going to get, let's say, 90% of the value out of the stream, and then there's 10% that they just don't have the time, or it's just too labor intensive to try to capture that other 10%. And so with using our technology, we're taking, instead of them taking that material to the landfill, we're bringing it to our facility, running it through our technology, trying to further clean it up and reduce the amount of waste going to the landfill.
What percentages are you pulling out of the residual?
Well, I'm not sure on the exact percents, but as much as we possibly can. We still are, like other facilities, we're still going to have some loss in there. But we are cleaning up as much as we can see, as much as we can find, and so I don't know the exact percent on there.
You still have a question?
Yeah. Let's have a system that runs 2 days a week, single stream, 3 days a week, mixed waste. Is a relatively simple issue to switch over to the different streams. In terms of the robot's knowledge.
Yeah. So if you want the robots to perform a certain task on Monday and Tuesday, and then a different task Wednesday, Thursday, something like that, it's really easy. We've got a HMI on the computer that it works like an iPad. You go up there and you touch it, and you tell the robot what you want it to pick and where you want it to put it. Very user friendly. I would say a lot of times our customers aren't doing that, but I see a lot of value in being able to do that, especially like for a smaller type operator that I mentioned earlier. A lot of these will be, let's say, straddled between 2 bunkers, and they'll be doing PET and HDPE, or they'll have a couple of chutes. Let's say on a fiber line, you want to pick out contaminants, and if you see anything recyclable, you want to put that in a different chute. get that over to your container line. So the programming often stays the same, but yes, it's very simple to change. And, even walked up to some with customers that, have robots running and say, okay, hey, let's see how much polypropylene is in here. It's kind of a hot topic right now. And so we'll just program it to pick polypropylene, and we'll just program it to throw it on the floor next to us and just see how much polypropylene is in the line. So very, very easy to do. And then also, going back to the data, being able to see, if you've got robots or vision systems on a container line, be able to see your different material streams. And if you're not picking polypropylene, how much do you have in there? And then we can what we usually do is just use a standard measurement and average weight. And then our operators will calculate value. Thermoform is also, kind of a up and coming hot topic right now. And so we've done the same experiment, just did one last week where we said, okay, you've got this robot on the container line. Right now your thermoform's just going in with your PET. Let's see how much you've got there. What would the value be if we started pulling that out? And should we get another robot to just focus on thermoform?
Any other questions?
I'm just curious, you have multiple arms for one brain. So if you could have just the one brain and scanning going on front, could you have multiple arms behind that? Because it sounds like the brain is going to be like the expensive part versus the arm being however much money it is.
Yeah. So the question is, can you have multiple robots per one brain? The answer is yes, you can. And matter of fact, on our tandem robots, which is our side-by-side robots, that they do operate off of one brain. The trouble is that we've found is if, let's say we just use one brain and then had like 6 robots behind it, the trouble is the material shifts along the way. And so if I'm going to, go after a piece of cardboard, it might roll a water bottle off of it, which hits something else. And so we played with that early on, that kind of setup. But ultimately, we found what's best, and like what you'll see if you see a couple of our robots in a line, is that we'll have a vision system and a brain between each of those robots. And that gives us the most accurate way to pick.
I'm going to apologize if you covered this already, and I don't know if this is a fair question or not. But if you have, let's say you're processing 100,000 tons of single stream recycling, can you give me an idea of the ratio between humans to robots on average?
So 100 tons a day?
Sorry, 100,000 tons a year.
Okay. The best way, since we don't do weight, the simplest way for us to look at it is the humans do about 40 picks per minute and the robots do about 80 picks per minute. So the equivalent there would be one robot system replaces 2 human sorters. And then you just, for the ROI, then you look at how much that costs, how many shifts you're doing, if you're doing 1 shift or 2 shifts, and then really add up the hours of the worker and compare that. So obviously the more time that you're employing humans, is the ROI is going to be better for the robot because the cost stays the same. It seems like 2 years ago, a lot of people wanted to buy the equipment outright and just write a check. But as the markets have been down and things have been uncertain, a lot of people are now doing a finance purchase over 60 months. And so they can literally take that cost that they're paying monthly for the humans and just start paying the robot for that. And so that's been a really good way for MRF operators to acquire this equipment without having to write a big check.
Thank you.
Any other questions?
Thanks so much for letting me share, and thanks again, Gene, for putting the conference on, and thanks, Sidney, for the warm intro.
Thank you.
Yep.
Have we still got David and Kevin on, or are they signed off?
No, I'm still there.
Okay. Is there any questions that anybody may have for these two guys, for any of the three? Since we still have David, I think, online, and I don't know about Kevin.
Yep,
One
I'm
question,
here.
one question real quick I had, and it's probably a crazy question, but for Richmond and David, the width of your conveyors, the width of the conveyors, do you want it a certain width, or does it matter? Or, I know it can't go too wide, but is there something common there that you would use? I mean, what would you use for width?
This on?
Typically, for a robot conveyor that goes on a robot, the width of it?
I mean, I can jump in there, and you can correct me if I'm wrong, but I'm going to do a little bit of push on what you said as well. Is we need to single layer the material that's going under the vision system, so we're accurate at detecting what the material is. So that's a key point. So the narrower the conveyor is, if at the same tonnage or same capacity, the more likely we are to have material that is on top of the other in either mispick or misreading of the material. So we obviously want the conveyor to be as wide as possible. And since we're using the same home run robot arm, maybe you guys use other as well, but on our side we use home run robot arms. That allows us to pick on 42-inch wide belt and be able to still sort material on both sides, or go up to a 48-inch wide if we are only sorting material on one side. So that means that traveling from when you pick on the very far end side to the other will obviously slow the optimization, versus if you can sort on both sides of robots. So what I mean by sorting on both sides, I'm saying, if you pick something on the belt, you can, like that bottle of PD, for example, if it's closer to the right, you go to the right. If it's closer to the left, you go to the left, and you're still in the same bunker, for example. That's how you get faster pick. But we can go over a 36-inch belt, 30-inch belt, up to 48. And at that point, it just means that the investment gets larger because we can actually stagger robots. So we can still have one vision system that handles decision for the robots, but we can stagger two robots side by side, or a little bit one back of the other, so their circle of prehension is not affected by the other. And at that point, we can go up to a 72-inch belt wide.
Richmond?
Yeah, just to add to that, it's David's absolutely right. That 42-inch, 48-inch for a single arm. The smaller the belt is, the faster cycle times you're going to have. So like on our e-waste applications where the belt's really small, like a 24-inch belt, the robots are flying because it doesn't have to go as far. And so the wider the belt is, it's just going to have the more cycle time. So you can imagine like throwing a 60-inch hula hoop on a line. That's the reach of the total robot arms. And so that's why if we've got a 48-inch line, just throw to one side, because ultimately we've got about a 60-inch radius to work with per robot arm. Now for our dual systems, we go up to about a 72-inch belt. And so just a lot of the fiber lines that we're on will be a tandem robot, side-by-side robots. And to the gentleman's point earlier, it is a little cheaper because you're just running off one computer system, one vision system for two robot systems. And so that does help the price point. It's not quite as much as buying two single robots.
Yeah, I just had a question. We have C&D application. So obviously with the heavy stuff, that the robotics are not there, but when you have your cut and you have small dimensional pieces of wood, you may not have the full, like a plastic bottle goes over the full suction cup, but and ridiculously small would be like a pencil size. Is the suction able to pick up something that is, an inch or a half an inch in width?
We like, a good visual for me is something the size of a credit card. It's about as small as we'll say, at least in our literature, that we can pick up. Now, can we pick up a pencil? Yeah, it probably would get a pencil. It certainly is going to identify it and know it's there. We also have our algorithms, kind of what I was talking about on the robot control system. It's going to be depending on, let's say your priority is wood to pick out and it sees that pencil, but then there's a a big piece of film after it that you also say you want to remove contaminants, which film would be a part of. So the algorithm's going to work in such that even though wood is the priority, it's a smaller piece than the bigger contaminant that's a less of a priority. And so it's going to actually plan to pick the big piece of contaminant versus the little piece of wood because of the payload and all that. But in general, things like pencils and straws and forks and knives and things like that are more difficult for the suction because it can't get, you know, a good seal on it. But because of the flow of air around it, you know, it could have an opportunity to pick that up. But like something like a nail would be kind of hard because it's heavy and it doesn't have a lot of surface area to grab.
Any other questions? Anything else you guys want to say, David, Kevin, Richmond?
I'd just like to say thank you, Gene, and thank you, Sidney, for hosting, and really appreciate the opportunity. Wish I could have been there in person.
Me too.
I wish you could have too. That'd have been good. Next year.
Yeah.
Thank you, everybody, very much. Thank you.